Is about differentiation. The parametric equations of a curve are x equals 1 over cos t, y equals ln tangent t. Show that dy dx is... Okay, so from x equals 1 over cos t, this is the same as cos t to the power of minus 1. So we use the usual power rule. So using the usual power rule, we bring the power down. We have minus 1 times cos t to the power of n minus 1, so to the power of minus 2. Okay, so we use the usual power rule, but because the base is cos t, we have to multiply by the derivative of cos t, which is minus sine t. So the derivative of cos is minus sine in MF19. Okay, so in the end we have minus times minus is plus. We have sine divided by cos squared. And now for the ln tangent t. So the derivative of ln is 1 over, actually this is 1 over x, there's an x here. So the derivative of ln is 1 over x. So the derivative of ln tangent t is 1 over tangent t. But because we have something complicated here, not just x or t, this is tangent t, we have to multiply by the derivative of tangent. And the derivative of tangent is secant squared. So chain rule again. So 1 over times chain rule, the derivative of tangent, which is secant squared. Now we have this non-MF19 formula. Secant is 1 over cos. So instead of secant, we're just going to use 1 over cos. And we can simplify a little here. We have... Hold on. Okay, we cancel out the cos t and the power. So we have 1 over sine cos. Now to find the dy dx, so using the chain rule formula here, dy dx is the same as dy dt dt dx, because just like when we simplify fractions, this is actually dy dx. So the dy dt is just like this is dy dt, so just rewrite. Now for the dt dx, be careful because what we have here is dx dt, and what we need is dt dx. So we're gonna have to use the reciprocal. We're gonna have to flip this upside down, and we use cos squared over sine. And we can simplify now. We have cos cancel out with the square here, and the sine times sine becomes sine squared. So we get what we need to prove. Next part, find the equation of the tangent to the curve at the point where y equals 0. So first of all, we have y equals this, x equals this, and dy dx equals this from the previous part. So to find the equation of the tangent, we're gonna have to find the gradient and one point on the line. So to find the point, we know that the y coordinate is 0. Now we need to find the x coordinate. So to find the x coordinate, we find the t value first. So when the y is 0, we solve for t. So here we do e to the power of both sides. On the left, e to the power of 0 is 1. On the right, e to the power of ln cancel out. We have only the argument of the logarithm. So we have only tangent t. And then to find the t, we use inverse tangent. So the t is inverse tangent 1. We have to use radians, so pi over 4. So the t is pi over 4. We can find the x value. We replace the t with pi over 4. We get the x value. So now we have the coordinates of the point on the line, which is root 2 comma 0. The y is 0. So root 2, 0. And to find the gradient, we use the dy dx. This is the dy dx from the previous part. We replace the t with pi over 4, and then use a calculator. We get root 2. So this is the dy dx when the y equals 0 and the t equals pi over 4. So now we have the gradient and the point on the line. We use the y minus y1 formula. So we plug in the y1 is 0, the x1 is root 2, the m is root 2, and then we simplify. This is just y. this is root 2x, root 2 times root 2 is 2, so we have the line equation, the tangent line equation. Alright, I'll see you again next time.